A basis of MATLAB's strength comes from its diverse collection, or library of functions. These functions perform an equally diverse variety of operations, and many of them are named after these operations. Some examples include sum, mean, read file, square root, zeros, length, size, rand, and plot with its related functions xlabel, ylabel, title, and color. These will be covered in more detail later due to their widespread usage. First, let's learn how to use MATLAB's help function to adjust our syntax. Suppose we want to generate a random number using MATLAB's built-in rand function. We know that the name of the function is rand, but we are not sure how to format our input. Simply type rand, and with your cursor at the end of the phrase, press F1, or right-click and select Help on Selection. Note also that you may highlight the phrase rand and hit F1, or use the function browser via Shift F1. Finally, you can also type help rand to output a plain text version of the documentation. Going back to our F1 rand help file, under the syntax category are all the patterns of input that the function accepts. You can see that for the rand function, it is acceptable to use one matrix, two matrices, more than three inputs, and even textual or string inputs. While each of these formats serves a different purpose, more than often the basic functions you will be using require less inputs, which are near the top. Scroll down to the description portion of the documentation. Under this section, the developers addressed each form of input individually, describing what to place in the parentheses, or the input, and what the function returns for this number of input, or the output. If we read the documentation, we can see that rand n, with one argument, takes one input and returns an n by n matrix containing pseudo-random numbers that are uniformly distributed on the interval 0, 1. On the other hand, rand matrix m, n returns a matrix of size m by n, while rand MNP generates an array of 3 or more dimensions, filling it with uniformly distributed random numbers. The last two functions, rand ... double and rand ... single, returns arrays of the data type double or single. While it is doubtful that you will use data typing in MATLAB for most assignments, these data types determine the precision or number of decimal places of your numbers. For almost all cases you will encounter, these differences are negligible and do not merit further discussion. Notice also the blue hyperlinks linking to other related functions. For example, randn links to a normal random variable generator function. Notice also that you have a history of browsing within this window via the back and forward buttons. Finally, scroll down to the examples section in the rand documentation. Here is where the developers show you typical usages of the function. This example is essentially useful, and often you may copy and paste these lines directly into your window to test them out. Try this example. First, copy the line that they gave you, and close your window. Now we will try setting A to something, as well as B, and finally setting R1 to the line that they gave us. Notice that R1 is a 100 by 1 column vector with all values between 10 and 27, as stated in the example as part of the documentation. Now try R2 equals the same thing they gave us, but instead we will use 2 as our argument for rand instead of 100, 1. Now notice that R2 is a 2 by 2 matrix with the same range of values because we are now using the rand n form instead of the rand n, m form. Finally, try R3 equals the same thing they gave us, but this time we will use rand 3, 3, 3. Notice now that R3 is a 3 by 3 by 3 matrix of random values of the same range. You may or may not have noticed the period before the multiplication in all of these expressions. We can get a better sense of the matrix multiply or divide in the next example. First, let's define two new variables, x as 1, 2, 3, and y as 4, 5, 6. Suppose now that we wanted to multiply the two matrices. We know that we can only multiply n by m matrices by m by n matrices, so we can type mm equals x apostrophe times y to get the results. However, what if we wanted to simply multiply the corresponding elements of equally sized matrices together? Before, we simply transposed x to get the desirable dimensions, but to do this alternative form of dot multiply, we can use element by element multiply or divide, which is also commonly called the dot times, or dot divide. Try instead x dot times y. This will multiply x of 1 by y of 1, and so forth, and the same can be done with divide. Try x dot divide y. Now try x transpose dot times y, and notice that this will return an error because x and y are no longer the same dimensions. As a final note, you may also add single numbers to each element of a matrix with just the plus operator. In general, matrices can only be added or subtracted together if their sizes are the same, or if one of the matrices is a 1 by 1 matrix. As you can see from these examples, reading MATLAB documentation is essential to its proper usage. Moreover, this documentation often has helpful tips regarding the purposes of every function in its library. Finally, you learn an alternative method of multiplying matrices together with the dot operator.